As two hostile aircraft peel from formation at 40,000 feet, diving toward exposed ground units below, a blur of motion slices through the upper atmosphere. Out of the layered mist of contrails and sky, the Eurofighter Typhoon rolls inverted and pulls into a crushing high-G dive, cutting through altitude like a blade. Inside the cockpit, the pilot's visor floods with data, target vectors, closure rates, missile envelopes, all compressed into a single lethal choice. A pair of meteors slip from underwing pylons and vanish into the beyond, their ramjets kicking in with silent fury. At Mach 4, they don't chase, they ambush. The Typhoon simply arcs away, climbing back into the silence it came from. Its job done, its presence only confirmed by the absence of threat. It's about air dominance, and the Typhoon doesn't ask for it, it takes it. The Eurofighter Typhoon was not born out of convenience, it was born out of necessity. By the late 1970s and early 1980s, Europe's leading NATO air forces were flying a patchwork of aging Cold War-era fighters. Tornadoes, Jaguars, F-4 Phantoms, and Mirage variants still filled the ranks, but none could promise the kind of air dominance that would be required in the decades to come. The growing threat of advanced Soviet aircraft, coupled with the looming reality of beyond-visual-range missile engagements and high-speed dogfighting, made one thing clear. Europe needed a new kind of fighter. Not just a fast one, not just a lethal one. A fighter that could do everything. Intercept, strike, dominate, and do it better than anything flying against it. Thus began one of the most ambitious multinational defense collaborations in history. The Eurofighter program, initially conceptualized by the United Kingdom, Germany, Italy, and Spain, sought to develop a next-generation combat aircraft that would serve well into the 21st century. From the start, the design philosophy behind the Typhoon was centered on one uncompromising idea: air superiority first, multi-role capability second, but without compromising either. The resulting aircraft would combine the raw performance of a traditional fighter with the agility of a dogfighter and the situational awareness of an airborne command node. Development formally began in 1983 under the banner of the Future European Fighter Aircraft Program, and after many political and industrial twists, including the withdrawal of France, which went on to build the Dassault Rafale, the Eurofighter Consortium was officially established in 1986. By 1994, the first prototype took to the skies, and by 2003, the Typhoon entered frontline service. In the realm of modern fighter aircraft, the Eurofighter Typhoon distinguishes itself through a design that harmoniously blends agility, speed, and advanced aerodynamics. Measuring approximately 52.4 feet in length, with a wingspan of 35.9 feet and a height of 17.3 feet, the Typhoon's dimensions position it between its European counterparts, the Dassault Rafale and the Saab JAS-39 Gripen. The Rafale, slightly shorter at 50.2 feet in length and a wingspan of 35.4 feet, and the Gripen, more compact at 46.3 feet in length, with a wingspan of 27.6 feet, reflect different design philosophies tailored to specific operational requirements. Central to the Typhoon's exceptional maneuverability is its canard delta wing configuration. This design choice, characterized by a delta wing complemented by four mounted canard surfaces, imparts the aircraft with inherent instability, a deliberate feature that enhances agility. The canards, positioned ahead of the main wings, generate additional lift and contribute to the aircraft's ability to execute rapid pitch changes, while also influencing airflow over the wings to delay stall onset during high-angle maneuvers. This
This configuration, managed by a sophisticated quadruplex digital fly-by-wire control system, allows the Typhoon to achieve superior performance in both subsonic and supersonic flight regimes. The fuselage design further complements the aircraft's aerodynamic efficiency. Constructed using lightweight composite materials, comprising approximately 70% carbon fiber and 12% glass fiber, the airframe achieves a balance between structural integrity and weight reduction. This extensive use of composites not only contributes to the Typhoon's agility, but also enhances its radar signature management, as the materials and shaping techniques employed help minimize radar cross-section, particularly from the frontal aspect. At the heart of the Eurofighter Typhoon's exceptional performance lies its twin Eurojet EJ200 engines, each delivering up to 20,000 pounds force of thrust with afterburner. These advanced turbofans enable the Typhoon to achieve speeds exceeding Mach 2 at altitude. Notably, the aircraft can sustain supersonic cruise without afterburners, a capability known as supercruise, allowing it to fly at speeds around Mach 1.5 while conserving fuel and reducing infrared signature. The Typhoon's range is equally impressive. With external fuel tanks, it can cover distances up to 1,800 miles, providing significant operational flexibility for various mission profiles. Its service ceiling surpasses 55,000 feet, granting it a tactical advantage in high-altitude engagements. Flight characteristics of the Typhoon are enhanced by its canard delta wing configuration and digital fly-by-wire control system, offering exceptional agility and responsiveness. The aircraft can perform rapid climbs, reaching altitudes of nearly 36,000 feet in just 2 minutes, making it ideal for quick reaction alert duties. At the core of the Eurofighter Typhoon's combat prowess lies its sophisticated radar and weapon systems, meticulously engineered to ensure dominance in both air-to-air and air-to-ground engagements. The Typhoon's radar system has undergone significant evolution, transitioning from the mechanically scanned Captor-M to the advanced Captor-E active electronically scanned array radar. The Captor-E, developed under the European Common Radar System program, introduces several variants that offer enhanced capabilities. Notably, the ECRS Mark II, developed by Leonardo UK, provides simultaneous radar functionalities, air surveillance, air-to-ground targeting, and electronic warfare capabilities. This radar system enhances detection and tracking ranges, offers a wider field of regard, and improves resistance to jamming, thereby significantly boosting the Typhoon's situational awareness and combat effectiveness. Complementing the radar is the passive infrared airborne track equipment system, an infrared search and track sensor mounted on the port side of the fuselage. Pirate enables passive detection and tracking of multiple targets, providing high-resolution imagery and enhancing target identification without emitting detectable signals. This system allows the Typhoon to operate effectively in environments with heavy electronic countermeasures and contributes to its stealth capabilities by reducing the need for active radar emissions. The Typhoon's weapon systems are equally versatile. For air-to-air combat, it can be equipped with a range of missiles, including the AIM-120, AMRAAM, AIM-9 Sidewinder, Iris-T, and the MBDA Meteor Beyond Visual Range missile. The MBDA Meteor missile represents a significant advancement in air-to-air combat capabilities, particularly when integrated with platforms like the Eurofighter Typhoon. Its design incorporates a solid-fuel variable-flow duct rocket, commonly referred to as a ramjet, that provides sustained propulsion throughout the missile's flight, enabling it to maintain speeds exceeding Mach 4. This continuous thrust allows the Meteor to engage targets at extended ranges, with an operational reach surpassing 100 kilometers and a no-escape zone estimated at over 60 kilometers, surpassing many current medium-range air-to-air missiles. The Meteor's guidance system combines inertial navigation with mid-course updates via a two-way data link, culminating in terminal active radar homing. This configuration ensures high accuracy against maneuvering targets and resilience in environments with electronic countermeasures. The missile is also equipped with both impact and proximity fuses, enhancing its effectiveness against a variety of aerial threats. In air-to-ground roles, the Typhoon can deploy precision-guided munitions such as the Paveway series of laser-guided bombs, the Storm Shadow cruise missile, and the Brimstone missile. The Storm Shadow, with its long-range and bunker-penetrating capabilities, allows the Typhoon to strike high-value targets from a safe distance, while the Brimstone missile provides precision strike capabilities against moving and static targets, including armored vehicles. The Eurofighter Typhoon's electronic warfare and data link systems are integral to its role as a modern multi-role combat aircraft, providing advanced capabilities for threat detection, situational awareness, and mission coordination. Central to the Typhoon's EW suite is the Praetorian Defensive Age subsystem, developed by the Euro-DAS consortium comprising BAE Systems, Electronica, and Indra Sistemas. This integrated system offers comprehensive protection through electronic support measures, electronic countermeasures, missile approach warning systems, laser warning receivers, and a towed radar decoy. The ESM component provides 360-degree detection of radar emissions across a broad frequency range, enabling the identification and geolocation of potential threats. The ECM deploys digital radio frequency memory techniques to jam or deceive enemy radar systems, enhancing the aircraft's survivability in contested environments. The MAW utilizes active millimeter-wave radar to detect incoming missiles, triggering automatic deployment of countermeasures such as chaff and flares. The LWR alerts the pilot to laser-guided threats, while the TRD extends the aircraft's defensive perimeter by luring radar-guided missiles away from the Typhoon itself. In terms of data link capabilities, the Typhoon is equipped with the Multifunction Information Distribution System, which facilitates secure, high-speed communication and data sharing among Allied forces. This system supports functions such as real-time tactical data exchange, enhancing situational awareness and enabling coordinated operations. The MIDS allows the Typhoon to participate effectively in network-centric warfare, integrating seamlessly with other platforms and command structures. Recent developments have further augmented the Typhoon's EW and data link capabilities. The Royal Air Force has introduced the Storm Shroud unmanned aerial vehicle, designed to operate in conjunction with manned aircraft like the Typhoon. Equipped with the Bright Storm electronic warfare payload, the Storm Shroud UAV can jam enemy radar systems, providing an additional layer of protection and expanding the operational envelope of the Typhoon. This concludes our episode that provides a glimpse into the mighty Eurofighter Typhoon. There are, of course, many other remarkable fighter aircraft in the world. So what do you think about Eurofighter? Also, if you were lucky enough to see a Eurofighter Typhoon up close, or better yet, flew one,